10.6 is on right triangle trigonometry. So the heights of mountains can be found using trigonometry. The word trigonometry means measurement of triangles. Trigonometry is used in navigation, building, and engineering. For centuries, trig was used with the stars for navigation and to record the locations of stars and figure out the motion of the moon relative to the Earth. Today, trig is used to study the structure of DNA. So the right triangle forms the basis of trigonometry. If either acute angle of a right triangle stays the same size, the shape of the triangle does not change even if it is made larger or smaller. Because of the properties of similar triangles, this means that the ratios of certain lengths stay the same regardless of the right triangle size. These ratios have special names and are often defined in terms of side opposite an acute angle, the side adjacent to the acute angle, and the hypotenuse. And so you can see below, we've got corners or angles A, B, and C, and then we've got our sides A, B, and C, and the small a lies opposite of the corner A. Side B lies opposite of the angle B, and side C, which is the hypotenuse, is the opposite of our right angle. The three fundamental trig ratios, sine, abbreviated to just SIN, cosine, or just COS, and tangent, TAN, are defined as ratios of the lengths of the sides of a triangle. Of a right triangle specifically. So let A represent an acute angle of a right triangle with right angle C, shown in the figure above. For angle A, the trig ratios are defined as the side opposite angle A over the hypotenuse, or little a over C. The cosine of A is the side adjacent to angle A over the hypotenuse, or this is side B over C. And the tangent of A is the side opposite angle A over the side adjacent. This is A over B. And so there's a shortcut that we use to memorize, and it's Sohcahtoa. And so the S stands for sine, which is then opposite over hypotenuse. Cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. So find the sine, cosine, and tangent of A. So we have, excuse me, we have 5 and 12. Now remember, the side that's opposite the angle is what letter it represents. So this 5 is side A, and 12 is side B, and we need to find C. Now because this is a right triangle, we can use the Pythagorean Theorem to figure out side C. So that's A squared plus B squared equals C squared. But this is 5 squared plus 12 squared equals C squared. We got 25 plus 144 equals C squared, and that's 169. And so taking the square root, we get that C is 13. And so we need to find the sine of A, cosine of A, and tangent of A. So the sine of A is opposite over the hypotenuse. So the side that's opposite of A is little a over C, which in this case is 5 over 13. Cosine of A, which is adjacent over hypotenuse, That is b over c. Which is 12 over 13. And the last one is tangent of A, which is opposite over adjacent, and that's A over B, and this gives us 5 over 12. If we are given the length of one side and the measure of an acute angle of a right triangle, we can use trigonometry to solve for the length of either of the other two sides. So we're going to use the right triangle below to answer the following questions. First is to find side A, and then we need to find C. So using the angle that's given other than the right angle, which in this case is A, which is 40 degrees, we know we're looking for little a, which is the opposite side of our 40 degrees. And we were given the side that's adjacent, which was b equals 150 centimeters. So because we are looking for the opposite and we're given the adjacent in regards to the 40 degrees, we can use tangent to figure it out. So the tangent of 40 degrees equals, and that's opposite, which in this case is the A we're looking for, over adjacent, which is 150 centimeters. And now solving for A, all we're going to do is we're going to multiply by 150 on both sides. So on the right hand side it cancels. We're just left with A. So A equals 150 times the tangent of 40 degrees. And putting that into your calculator, you get 126, and it would be centimeters. Now we can do something similar for C. Again, we still want to use the angle that was given, which is the 40 degrees. But now we're looking for C, which is the hypotenuse. And we still have the adjacent. So adjacent and hypotenuse is the cosine. So the cosine of 40 degrees is equal to, that's adjacent, which in this case is 150, over the hypotenuse, which is C. We are going to multiply by C on both sides so we can get rid of the denominator. So we have C times the cosine of 40 degrees equals 150. And we want to solve for C. So we are going to divide by cosine of 40 on both sides. So on the left they cancel, and we just get C equals 150 over cosine of 40, which gives us 196 centimeters. And we just want to finish up this section with some applications of trig ratios. So trig was first developed to determine heights and distances that are inconvenient or impossible to measure. These applications often involve the angle made with an imaginary horizontal line. An angle formed by a horizontal line in the line of sight to an object that is above the horizontal line is called the angle of elevation. The angle formed by a horizontal line in the line of sight to an object that is below the horizontal line is the angle of depression. So you can see in the figure below that the plane would be the above our horizontal line, so that would be an angle of elevation, and then looking down at the car below would give us an angle of depression. So from a point on a level ground 125 feet from the base of a tower, the angle of elevation, which means we are looking up to the top of the tower, is 57.2 degrees. Approximate the height of the tower to the nearest foot. So with these, I always think it helps to draw a picture. So we're on horizontal ground, and it's going to be a right triangle. And an angle of elevation means that you are looking up. So you can just pretend you're sitting down here and you're looking up. This angle that's by us is 57.2 degrees. We want to know the height of the tower. We are also 125 feet from the tower. So if my tower starts over in the right angle, so we are given 57.2. We have the opposite side we're looking for, and we're given the adjacent side. So we're going to use the tangent of 57.2 equals x over 125. We are going to multiply by 125 on both sides. So they cancel on the right. And we have x equals 125 times the tangent of 57.2, which is 194, and this would be in feet. Now, if the measures of two sides of a right triangle are known, the measure of two acute angles can be found using inverse trigonometric keys on a calculator. And so if you're using a TI 83 or 84, you would click the second button, and then you would click, if it's an inverse sine, you would click the sine button. If it's the inverse cosine, you would hit second cosine, or if it was inverse tangent, second tangent. So a building that is 21 meters tall casts a shadow of 25 meters long. Find the angle of elevation of the sun to the nearest degree. So I'm going to draw my right triangle here. This is my building over to the left. It's 21 meters tall, and it casts a shadow of 25 meters long. I want to find the angle of the elevation of the sun to the nearest degree. So shadows always go behind you, which means that my sun would have to be up in this top corner. And so we would want to know the angle of elevation over in the opposite corner. And so I'm just going to label this as A. And so we're given the opposite and the adjacent again. So we have the tangent of A. We don't know A, we're looking for A, equals 21 over 25. Opposite over adjacent. Now to undo the tangent, we use the inverse tangent. And so the inverse tangent, it looks like a tan with a -1 power of our function. And what we do to one side, we have to do to the other. On the left-hand side, the inverse tangent and the tangent cancel. And so we're just left with A equals the inverse tangent of 21 over 25. And so plugging that into your calculator, you get that A equals 40 degrees.